This rebar check keeps your structure safe.
We'll move on to the checking of the reinforcements for the columns and shear walls. Let's start with this column right here, the CA2 column. As QAQC inspector, our first step is always to verify the shop drawings. We need to check the specifications including the diameter of the bars, the spacing, and the type of steel required. So for this CA2 column, let's pull up the drawing and confirm it if the actual site installation matches what's required. So first, let's check the splicing length of the column reinforcement based on the approved drawing. According to the detail, the required lap splice is 50 times the bar diameter. In this case, we are using T20 bars, so we calculate 20 mm times 50 equals to 1000 mm or 1 meter. This means the minimum lap length should be 1000 mm or 1 meter. Now we have verified the actual splice length on site, and it measures 1 meter, which is the required 1000 mm. That means the splicing provided here is acceptable and complies with both the drawing and standard requirements. We are doing this splice because we are currently at the 5th floor level of the building and the column has future bars extending upward. These bars will be spliced with the next vertical reinforcement once the next floor is cast. Let's now check the vertical reinforcement. In the lower floors, the bars used are T25, but here on the upper floors, it's reduced to T20. This is normal because lower floors carry more load, so they need bigger bars. As the load decreases on higher levels, smaller bars like T20 are sufficient. Next, we verify the quantity. On site, we inspected and found 20 vertical T20 bars. The drawing, however, shows 22 bars, which appears to be a typographical error. To confirm this, we cross-check with other similar column details, and they consistently show 20 bars. We recommend raising an RFI or request for information to verify and document this officially. Next, we check the spacing of the links. As per the approved drawing, the spacing is 160 mm near the top and bottom, close to the slab soffit level or the SSL, and transitions to 200 mm at the midspan of the column. This because it helps resist higher shear and confinement forces, while wider spacing at midspan is sufficient due to lower stress in that area. We also verify the type of lateral ties used, whether they are single or with cross ties as shown in the drawing.
Like and follow for more real site tips.